So in this video, I would like to explain how you can troubleshoot performance issues when data is not fast enough ingested into Elasticsearch. And for that, there are a number of information you can use to troubleshoot this and to see why data is slowing down or why the entire solution cannot stay real time with the API requests that are executed by your API gateways. And in this video, I would like to tell you how to get that information, how to read that information, and compare it with, let's say, with healthy situations. So first, I would like to start with Filebeat and something that is called back-pressure. You know that once an API request is executed on one of your API gateways, Filebeat has the responsibility to read that file, to stream that information further on to Logstash. Logstash will execute some pipelines with the help of Memcached and a REST API provided by an API Builder application. The data is enriched and then it is finally stored into Elasticsearch. And when this process is at some places not fast enough, for instance, Logstash, the pipeline is not fast enough, or Elasticsearch has a problem to store the data fast enough, then ultimately Logstash gets into trouble. And Logstash is telling Filebeat, hold on, please slow down. And then Filebeat is basically making a stop, sending further requests to Logstash because the queues on Logstash are full, and you can see that. And I would like to show you how you can identify such a back pressure. You do this basically by looking into the Elasticsearch stack monitoring. And in stack monitoring, when you're looking at the beats and you see a graph as it is shown here, then you know that your Filebeat has back pressure. So let me show that to you in real time. So this is my API gateway, or my API gateways. And as you can see, I'm receiving a few messages, or have received a few messages in the last 10 minutes. And I have connected the Elastic environment to that API gateways. And here's the real-time traffic monitor. And when I refresh that screen, you can see that it is not really real-time. So that means the system is really running behind, is not able to catch up with that data, because you see 0 data point has been stored in Elastic or saved in Elasticsearch since, I don't know, the last 5 minutes. And this is because the data or the ingestion rate of data is not fast enough to catch up with the data as they are produced. So in Kibana, you have the possibility to use stack monitoring. And stack monitoring provides you detailed analytics metrics about all the different components like Elasticsearch, Kibana, Logstash, Beats, and also the application performance management server. And I would like to start with that Beats section. I have 2 API gateways running, and these 2 API gateways are sending events into Elasticsearch, and very obvious that's not fast enough. And this looks not too bad. I mean, I have no failures, I have no output errors, I have some kind of throughput. That looks good. But let's check for the individual instances and see what they are reporting. And here it becomes very clear that something is not correct, because Filebeat basically tries to send data and then it's falling to 0. Even it has thousands of documents still to be processed, it's going to 0. And then after that back pressure, after that stop period, it tries again and again. Logstash is saying, no, please hold on. And this is a typical indicator if you have a Logstash, if you have a back pressure issue on Filebeat. And this is now could be several reasons for that, but very unlikely Filebeat itself is the reason for that problem. So it's more about Logstash, it's more about Elasticsearch. So something over there is not fast enough, and we will check for that as part of that video. So as Filebeat is very often not the root cause of the problem, you have to check for the next component, which is Logstash. And here you should check for the event latency as part of the stack monitoring. And the event latency should be between 5 to 10 milliseconds to process the data as part of the pipelines and send it into Elasticsearch. And here is, for instance, an example where the latency is way too high and very likely is going to cause problems. So if I now check for my system and go to Logstash, I see I have 2 nodes, but my latency here in that case is way too high. And I check for the nodes and I can see that my node is around 100% CPU usage and the other one is not used, but this is just because of the Elastic and of the Kubernetes-based deployment. But this here is heavily under load. And if I check this, then I can see here that latency problem. And in order to figure out where this latency problem is coming from, you have to go into the pipelines. So as all the documents are going through Logstash pipelines, you can use stack monitoring to get more details about the individual pipelines. For this solution, we have a number of pipelines. And the first one is the beats input pipeline, where each document is going through and that pipeline only is splitting up and routes the document into the next correct pipeline based on the type of data. And the other important pipeline you should look for is the open traffic pipeline. And when you click on such a pipeline, you get very comprehensive metrics about that pipeline, which helps you to understand where the time has passed and why is the event latency so high. So let's check for the real system. And I can go here into my pipelines. And then from there, I can go into the open traffic event pipeline. And I know that simple operations like a mutate should not take that long. It should be something like 0.0.1.2.3. Also, this one here is, of course, way too slow. And if you check, most of the operations here are just way too slow. And that's because I have not given enough CPU power to my Logstash, and that's why it just takes too long. So this is just for the sake of this video to make Logstash very, very slow. So when this happens, then you know it's something with, let's say, with your Logstash itself, it doesn't have enough power to run the filters fast enough. If you scroll down to Elasticsearch or to the outputs, so after the document has been passed all the filters, it's going into an output. So also here, the communication with Elasticsearch is impacted by the CPU limitation of Logstash, because normally it takes less than 1 millisecond to store a document in Elasticsearch. If it is much higher and Logstash has no performance issue in general anymore, then very likely the problem is on Elasticsearch side. So I have now reconfigured my Logstash configuration so that it can use more CPUs. And with that, of course, the CPU usage here is going down. And with that, I can go into the pipelines configuration and see how it should look like when, let's say, CPU is not an issue. And now you can see that, for instance, simple tasks such as JSON, such as date, mutate, everything is really, really fast in that area. Also, the communication with Elasticsearch is less than 1 millisecond when Logstash is no longer CPU bound. One important note is that this date interval has no impact or is not used for that messages per second. So that means I can change that to, I don't know, let's say 5 hours ago. Nothing happens here because this is a fixed interval from the last hour. So that means if you change something in Logstash, your configuration, more CPU, more memory, whatever, you have to be patient to see to see the execution details of your pipelines change. It takes an hour. So in this section of the video, I would like to talk about the caching of that API details and also about the application details. And as you may know, the solution is using caches, especially MEM caches, to cache information that has been obtained from API Manager by that API Builder Application REST API. And this is obviously based on the event information that has been passed on by Filebeat to Logstash. And especially for the API details, the HTTP exposure path is used as a key for the cache. And that example here, you can see it is using that path, which is named pet store v2 store inventory. Then as part of the Logstash open traffic pipeline, it's performing a lookup into Memcache if the API details are already present. And if not, then Logstash is doing a REST API call to API Builder, which is caching on its own, but finally talks to API Manager to obtain the API details. So there might be situations where this is not fully functional, let's say not fully working as expected. And the situation is when path parameters are used, because then by default, it will execute a cache lookup with a dynamic part with that custom ID, pet ID, whatever. And that's why most of the time Logstash will have a cache miss. And that's why it will always talk to API Builder to obtain the information, which works. It will find the API details, but of course, it will reduce or it will increase the latency and it will reduce the document ingest rate. Ultimately, you can see that in the application performance management of Kibana when looking at the API Builder for Elastic application. At the top section of this page here, you can see how it should look like in general. And so that means you see that there are throughput, that there are made API calls to that lookup API, but then for a few minutes, let's say for 10 minutes, for 5 minutes, there are no lookups performed because this is the place, this is the time when the information has been cached already by Logstash, and that's why API Builder is not used. But when you see an application performance management, something like illustrated below, that constantly requests are made to that API, to that lookup API, then you can investigate, and then you should, then maybe you end up in a problem having either an impact on the API manager in terms of performance because the REST API is then, let's say, heavily stressed by that solution, or the other impact is just that documents are not indexed into Elasticsearch fast enough. So, and for that, there is a dedicated parameter which has been introduced into the solution recently, which is named Cache API Path. And the purpose of this parameter is to tell Logstash when an API path is starting with one of the configured paths, then it should not use the given path in the open traffic event log file. It should use the path given here as part of this parameter as the cache key. So, and to demonstrate that, I have a number of APIs in my API Gateway Manager that are using that path. So that means I have here that pet store v2, which has a dynamic path. So let me just refresh that. And then very likely you can see path, and then we search for pet. So you see I have always other numbers, and this is then causing a problem with the cache lookup. So I go here into my Kibana, I go into APM to see that API Builder is basically called constantly all the time. And to get it a little bit more precise, I go into the transactions, and then I can select for the lookup API. And then I can see here, yeah, the lookup API is constantly called, or let's say we are checking this for the last 30 minutes, and you see it's really constantly called. And that's not the purpose. API Builder, that REST API, should only looked up when necessary, but most of the time it should be taken out of the cache. You can also see that in the stack monitoring when checking for the pipelines, and go into the open traffic pipeline. And then you see that section here, which is obtaining the API details. So it performs a memcache lookup for the API details. And if there are no API details, then it's going to get that API details from API Manager from via API Builder. And then, of course, the API details, once they are obtained, they are stored in memcached for the next time. And in 2% of the time, that doesn't work. So that means 2% of the messages that doesn't work. And then it's very costly to obtain that information from API Manager. And also it will increase the load on API Manager. You also see that in the overall latency, because it has an impact on the latency. So we are beyond that 10 millisecond latency threshold because of these additional lookups. And in order to configure that, I'm going into my YAML configuration, and I can now say that whenever an API path is starting with petstore v2 pet, or with careplan, or with any other API, I know that list can be pretty long, but there is no other way than configuring that. So that means I tell Logstash to cache API path like this. And let me now upgrade my infrastructure, my configuration, and then I will continue with that video because it takes a moment to update Logstash and restart Logstashes. So now after the configuration has been applied and Logstash has been restarted, you see the behavior has changed. So that means now it took a moment, but you can see now that API Builder, that API, that lookup API is no longer used for some time. And this also has an impact on the latency. Let's see if I go here. This is the time when I have restarted Logstash, which is pretty common to have a very high latency at that moment because all the information needs to be obtained. This is the values I got before, and sometimes I have 11 milliseconds, sometimes I have 8, 9, and so on. And this is now the average is about 3, 3.1, around 3, maybe 3.5 after we have made that changes. And it's not necessary to configure this parameter for all of the APIs you have. You just have to monitor if Logstash is called for some of your APIs very often, and you can do this by checking into your API Builder log files to see which APIs are constantly called, constantly asked, and put them into the configuration. If you have an API that is called once a day, or I don't know, 10 times, 100 times a day, it doesn't matter to configure that or not. So that means you need to monitor your system if it has an impact or not. So let me conclude. I'm not going into the details of Elasticsearch itself. So that means when you see in Logstash at the end of the pipeline in that output section, sending data, sending documents to Elasticsearch, and that time is increasing, then it's a clear indicator that now the bottleneck is on the Elasticsearch side. And the best advice at the moment would be to add more Elasticsearch nodes. Of course, there are other possibilities in terms of adding or assigning dedicated roles to different Elasticsearch nodes and so on, but that's an entire topic on its own. So one more thing I would like to share with you is that reference images, at least for your information about these images in stack monitoring, that gives you reference values which you can use to compare with your environment. So that means there is, for instance, a Beats overview picture which you can use to see, okay, what is the typical or what is the possible event rate for a Filebeat, what is the throughput, etc. That's the idea of these information so that you can compare it with your system to see are you in a range of something normal or not normal. These images has been taken out of the tests that have been made with that solution. And with that, I'm at the end of this video, and I really hope it was helpful to you. And thanks for watching.